Material handling equipment (MHE) is mechanical equipment used for the movement, storage, control, and protection of materials, goods and products throughout the process of manufacturing, distribution, consumption, and disposal. The different types of handling equipment can be classified into four major categories: transport equipment, positioning equipment, unit load formation equipment, and storage equipment. Their application helps with forecasting, resource allocation, production planning, flow and process management, inventory management and control, customer delivery, after-sales support and service. A robotics material handling system and processes are put in place to improve customer service, reduce inventory, shorten delivery time, and lower overall handling costs in manufacturing, distribution and transportation. There is a variety of manual, semi-automated and automated material handling equipment and technologies available to aid in the movement, protection, storage and control of materials and products throughout manufacturing, distribution, consumption and disposal. These include automated storage and retrieval systems, automatic guided vehicles, AGVs, automatic identification and data collection, ergonomics, hoisting equipment and industrial robots. Material handling systems are used in every industry, including aerospace, appliance, automotive, construction, consumer goods, e-commerce. When designing a material handling system, it is important to refer to best practices to ensure that all the equipment and processes, including manual, semi-automated and automated, in a facility work together as a unified system. By analyzing the goals of the material handling process and aligning them to guidelines, such as the 10 principles of material handling, a properly designed system will improve customer service, reduce inventory, shorten delivery time, and lower overall handling costs in manufacturing, distribution and transportation. These principles include planning, define the needs, strategic performance objectives and functional specification of the proposed system and supporting technologies at the outset of the design. The plan should be developed in a team approach, with input from consultants, suppliers and end users, as well as from management, engineering, information systems, finance and operations. Standardization: all material handling methods, equipment, controls and software should be standardized and able to perform a range of tasks in a variety of operating conditions. Work: material handling processes should be simplified by reducing, combining, shortening, or eliminating unnecessary movement that will impede productivity. Examples include using gravity to assist in material movement and employing straight-line movement as much as possible. Ergonomics: work and working conditions should be adapted to support the abilities of a worker, reduce repetitive and strenuous manual labor, and emphasize safety. Unit load: because less effort and work are required to move several individual items together as a single load, as opposed to moving many items one at a time, unit loads, such as pallets, containers or totes of items, should be used. Space utilization: to maximize efficient use of space within a facility, it is important to keep work areas organized and free of clutter, to maximize density in storage areas without compromising accessibility and flexibility, and to utilize overhead space. System: material movement and storage should be coordinated throughout all processes, from receiving, inspection, storage, production, assembly, packaging, unitizing and order selection, to shipping, transportation and the handling of returns. Environment: energy use and potential environmental impact should be considered when designing the system, with reusability and recycling processes implemented, when possible, as well as safe practices established for handling hazardous materials. Automation: to improve operational efficiency, responsiveness, consistency and predictability, automated material handling technologies should be deployed when possible and where they make sense to do so. Life cycle cost: for all equipment specified for the system, an analysis of life cycle costs should be conducted. Areas of consideration should include capital investment, installation, setup, programming, training, system testing